Here we're going to show the sum of Poisson probabilities equals a chi-square probability. And the Poissons, we're going to go from 0 to x, and the Poisson parameter is lambda. And then that equals the probability of being greater than 2 lambda when the variable is a chi-squared with 2 times 1 plus x degrees of freedom. And we'll start with this chi-square probability and shows that it equals the sum of the Poisson probabilities. So we start out with the probability, and then to be greater than 2 lambda is an integral with the chi-square degrees of freedom, or chi-square distribution, with 2 times 1 plus x as the degrees of freedom. And you end up with this. Now to integrate this, we're going to use integration by parts, x plus 1 times. And we'll do the first 3 or 4, and then we'll go dot dot dot. It equals, this. And so first we let u equal yx over x factorial. Dv is equal to now there is the 2 times 1 plus x, but I take one of the 2's and bring it over here, dy d2. I don't do that for the rest of them, but that's to illustrate that it makes this integration or antiderivative easier. So the derivative of this, the x comes out front, cancels with one of the factorials, we get this. The antiderivative, you get v, and then this breaks down to that. So then you get the uv part. So the u times v is this, and we're evaluating at 2 lambda and infinity, and then this is the v du part. Now one thing to look at this, when we plug in infinity, we get y, x, and then on the denominator we get e to the y over 2. And when you plug in y, it actually goes to 0. And you would need to show that using L'Hopital's rule several times. But that piece makes it go to 0. And then when you plug in 2 lambda here, so you get 2 lambda to the x. So the 2 to the x cancels with this 1/2 to the x. And then since it's this minus this, the minus and this -1 becomes positive. And then this boils down to, well, you'll see on the next step. And then here we need to do integration by parts again. And we chose this piece here because we're going to keep differentiating, and the exponent eventually will get to 0. And then when it gets to 0, then what's left over is really easy to integrate. So here the next step is u is equal to y raised to the x minus 1 over x minus 1 factorial. dv is what's left over, 1/2 to the x, e to the minus y over 2 dy. Differentiate, antiderivative, and then we get this piece. So this piece here simplifies to this, and this looks exactly like a Poisson probability evaluated at x. And then this piece here is, this is the first part of it. That's the uv evaluated from 2 lambda to infinity, and then this is the vdu component. And then when we evaluate this at infinity, then that goes to 0. And then when we evaluate this at 2 lambda, so you have 2 lambda raised to the x minus 1. So the 2 component cancels with this, and since it's this minus this, the minus and that -1 make it a positive. You have x1 factorial e to the minus 2. So in the next step, you will see what that equals. But then to evaluate this, we have to use integration by parts again. So then we keep evaluating. This is the u component, and the dv is the rest. And then you take the derivative, the antiderivative, and then you get this piece. So this piece and this piece is a sum from x minus 1 to x. And then this component, this is the UV of our substitution, evaluated at 2 lambda and infinity. And then this is the VDU component. And you just repeat until this exponent goes to 0. And then when it goes to 0, you get this, what's left. So it's the sum from 1 to x of the Poisson probabilities, and then the y component, raised to the 0, goes away, so we're left with this. And then to integrate this, you get this, and evaluated from infinity and 2 lambda. The infinity part makes it go to 0, and then minus a minus is plus, and you plug in 2 lambda. The 2's cancel, leaving just lambda. Well, then that is exactly what we were trying to show, that it's the sum of the Poisson probabilities. So anyway, I hope you enjoyed the video. If you like it, click the like button. Also subscribe so you don't miss the next video. Thanks. Bye.